In a surprising new development in space exploration, the James Webb Space Telescope has recently gathered some fascinating insights about Mercury, the closest planet to the Sun. For a long time, Mercury was seen as a barren, rocky wasteland, burned by the Sun's searing heat and overlooked in comparison to its more complex planetary neighbors. But recent findings have shown that our ideas about Mercury were wrong. It's actually a lot more mysterious and dynamic than we thought. Mercury is tiny, smaller than some of the largest moons in our solar system, and yet it has secrets that scientists are only just beginning to understand. One of the most surprising recent discoveries is that there might be diamonds scattered across its scorched surface. How can something as valuable and seemingly fragile as diamond exist on a planet that endures such extremes in temperature? It seems that the answer may lie in the cataclysmic events that Mercury faced early in its formation. Some scientists suggest that Mercury may have once been much larger, a planet that lost much of its outer shell in a huge collision. The intense heat and pressure from this impact could have transformed its carbon into diamond formations, just as happens with carbon here on Earth under extreme conditions. These diamond-strewn regions might just be remnants of that violent history, giving Mercury a precious geological legacy. And that's just the start of what Mercury has in store for us. There's a lot more to Mercury than meets the eye. Beneath its rocky surface lies a disproportionately large, dense core, much larger than expected for a planet of its size. This larger-than-expected core has piqued the interest of scientists, as it prompts questions about Mercury's past and its evolution. How did a planet smaller than the Moon end up with such a dense core? Some researchers think that Mercury's big core is proof that this small planet might have been much bigger at one point, losing its outer layers in a huge collision with something else in the early solar system. If this hit-and-run scenario is true, it could explain not only its dense core, but also its unique magnetic field, which is surprisingly strong given the planet's size and distance from the Sun. It was actually NASA's Mariner 10, the first spacecraft to visit Mercury, that discovered the planet has a magnetic field back in the 1970s. The Mariner 10 mission showed that Mercury has a magnetic field, just like Earth. It's not as strong as Earth's, and it's a bit unusual in that it's stronger in the northern hemisphere than the southern. The magnetic field on Mercury is different to that on Earth. On Earth, the field is generated by the motion of molten iron deep within the core. On Mercury, it's thought that the field originates from a different and less well-understood process. Scientists think that Mercury's magnetic field might be affected by its unusual spin and orbit pattern, which is called spin-orbit resonance. This makes it take 3 rotations on its axis for every 2 orbits around the Sun. This complex dynamic probably affects the motion of liquid metal in Mercury's core, generating a magnetic field that is far from uniform. The combination of Mercury's day and year creates another extraordinary phenomenon. Mercury takes 88 Earth days to orbit the Sun, but it takes 176 Earth days for it to complete 1 rotation on its axis. This means that 1 day on Mercury is twice as long as its year. For someone on Mercury, this would be pretty surreal. The Sun would rise, move across the sky, then slow down and reverse direction before continuing on its path. This strange dance is just one of many features that make Mercury a truly unique world, where time and space play out in a way unlike anywhere else in the solar system. But there's more to Mercury's mysteries than just its surface or its magnetic field. The Messenger spacecraft, which NASA launched in 2004, spent over 4 years orbiting Mercury, taking over 200,000 images and gathering valuable data on the planet's composition and history. The Messenger mission found high levels of calcium and magnesium on Mercury's surface, which is unusual for rocky planets. This suggests that Mercury has a unique geological history, possibly shaped by volcanic activity and ancient eruptions that resurfaced parts of the planet. Despite the intense solar heat, Messenger also made a surprising discovery near Mercury's poles: water ice. How can ice possibly survive on a planet that's so close to the Sun? The reason for this is that Mercury's polar craters are permanently in shadow from the Sun's rays. It seems that ice has been preserved in these dark, frigid pockets for potentially millions or even billions of years. The discovery of water ice raises some fascinating questions. So, could Mercury have had the right conditions for life, even if it was just microbial, despite everything that says it shouldn't have been possible? Could life forms survive in Mercury's icy craters, shielded from the sun's heat? It's similar to extremophiles found in Earth's most inhospitable places. Mercury's already extreme conditions are made worse by its thin exosphere, which doesn't protect the planet from the sun's intense radiation or space debris. This exosphere is mostly made up of oxygen, sodium, and hydrogen, and it constantly escapes into space, replaced by particles ejected by solar winds or micrometeorite impacts. Messenger also detected surprising levels of water vapor in this exosphere, which raises new questions about the sources and processes that release water on such a dry, desolate planet. This exosphere and its constant renewal provides scientists with a fascinating insight into how a planet stripped of a substantial atmosphere can still host a unique, dynamic environment. Mercury's environment is a bit of a study in extremes. During the day, the surface temperatures reach an incredible 800 degrees Fahrenheit, hot enough to melt lead. By night, temperatures drop to almost minus 300 degrees Fahrenheit. This huge temperature change is down to Mercury's lack of an atmosphere, which on other planets helps to keep the surface more stable. Without this protective layer, the surface of Mercury is exposed to relentless temperature changes that challenge our understanding of planetary environments. One of the most intriguing discoveries on Mercury is the so-called chaotic terrain near its southern pole. This area is marked by hills, valleys, and ridges that scientists think were formed by strong earthquakes caused by the sun's gravitational pull as Mercury's orbit shifted over time. These quakes might also be connected to the cooling and shrinking of Mercury's core over billions of years, which caused the crust to bend and break. Unlike Earth, where tectonic plates are constantly moving and changing the landscape, Mercury's surface shows the effects of a cooling planet with a single shrinking shell. Large thrust faults, visible proof that the planet is shrinking, give scientists clues about its internal structure and the forces shaping it. Recent studies suggest that Mercury has both a liquid outer core and a solid inner core, similar in structure to Earth's, but making up a much larger portion of the planet's volume. This makes the core of Mercury pretty unusual, and it could explain the geological activity that's been observed. Since there are no tectonic plates as Mercury's core cools and contracts, it forces the crust to wrinkle and crack, creating distinct features that offer clues to its mysterious past. Scientists have also found volatile elements on Mercury's surface, such as sulfur, potassium, and sodium, which usually vaporize at high temperatures. This suggests that comets or asteroids may have delivered these materials long after Mercury was formed, which gives us a new way of thinking about how inner planets close to the Sun might retain or acquire volatile compounds over time. The big question on everyone's mind is whether Mercury could ever have supported life, even under such extreme conditions. The discovery of water ice and organic compounds in Mercury's polar regions suggests that at some point, the planet may have had regions more conducive to life than previously imagined. Today, researchers are examining whether life forms similar to Earth's extremophiles, organisms that can survive in extreme conditions, might have existed or could even exist in Mercury's frigid polar shadows. Mercury is a planet of contradictions. It has an unusual day-night cycle, an oversized core, magnetic irregularities, and astonishing temperature variations. Studying Mercury is helping scientists learn more about its special features and how other rocky planets, including Earth, came to be. Mercury's core, mantle, and crust might hold the answers to how terrestrial planets evolve, lose mass, and adapt to their harsh environments. Its ancient, heavily cratered surface is one of the oldest in the solar system. It offers a living record of our cosmic history, a timeline that might just help us understand the earliest days of planetary formation. As we look forward to the upcoming BepiColombo mission, a joint project by the European and Japanese space agencies, we stand on the verge of potentially even more incredible discoveries. When BepiColombo reaches Mercury in 2025, it will delve deeper into the planet's surface and history, revealing secrets that could change how we see not just Mercury, but our entire solar system. Far from just a small, scorched rock, Mercury is proving to be a dynamic world with a story as complex and fascinating as any in our neighborhood in space.